Assalamualaikum warahmatullahi wabarakatuh. My name is Nuradila Hanis binti Hairudin and my matric number is P0217101168.
Given the importance of food status in life of today's society and its contribution to the economy, the improvement of food freshness become more important, but manual operation is time consuming. So, automatic grading using a computerized approach is believed to be the best solution for this problem.
The objective of the model first is to develop a deep learning model for eggplant classification. Second is to increase the accuracy and the perfection of the fruit freshness detection with the help of the size, shape and color based method with the union of convolutional neural network CNN. The third is to validate the performance of classification technique of deep learning model in terms of accuracy. Sustainability. Artificial intelligence may sprout from the world of computer wired circuitry, but may give us the sustainability solution we need to protect our environment from pollution, climate change, and etc. Deep learning neural network and synthetic data will provide AI with the data and framework needed to strive to achieve sustainability solution. In addition, deep learning can also be used to improve crop yield prediction to make them more environmentally friendly and less wasteful. For example, AI can help farmers to monitor their livestock and crop yield they expected.
Classification between objects is a complex task. Therefore, image classification has been an important task within the field of computer vision. Image classification refers to the labeling of image into one of a number of predefined classes. First thing first, we need to install some library that we needed to use later. So here is the data directory for all the data set. If you can see here, I will open the data set. Here data set we have A, B, C, grade A, grade B and grade C eggplant, and we also have train and validation file. So this is where the file is placed. So here is where we will display some of the eggplant from each of the grade. So this is some of data set from grade A eggplant, and this is the data set from grade B eggplant, and it's random data set from grade C eggplant. Here we will create a train datagen and a validation datagen. Train datagen and validation datagen is a image data generator. In here we can specify any augmentation we like. First, we will rescale the pixel value by multiplying to 1.255. For network architecture, I use convolutional neural network, ConvNet, known as CNN. CNN is a deep learning algorithm. Model type that I will be using is sequential. Sequential is the easier way to build a model. It allows us to build model layer by layer. In this layer, there will be 3 layers: input layer, hidden layer, and output layer. I have used a layered convolutional model with dense activation, flatten, dropout, and max pool 2D layers. The next method uses model to be compiled. Deciding which model to compile has many options like ADAM, RMS, PROP, and etc. The use of this model is to determine the optimization of the dataset model. After determining the optimization of the model, it is continued with the use of loss on the CNN function with the dataset class used. For binary classification use, we can use binary concentropy, and for multi-class, we can use categorical concentropy, and finally determine the accuracy metric to evaluate the model created. After entering the epoch and batch size, the next step is to enter a model evaluation from the trained data, and it is valid to see the result of the accuracy and loss use. As you can see here, the total accuracy for the train generator is 85%.
And the accuracy for the validation generator is also 85%.
This is the graph for the training and validation accuracy and training validation loss. After knowing the result of the classification values based on the accuracy, loss and confusion metric, so use the recapitulation to display the result of the evaluation of the data model with the variance of the parameter used, and save it in CSV format. So after all the training, we need to test it by predict the grade of the eggplant. So we will put an image of A eggplant, grade A eggplant, to test it out, and turn out it will give a result of grade A eggplant. And if we put an image of grade C eggplant, it will give a result of grade C eggplant. So the conclusion is it can detect whether it image of grade A eggplant or grade C eggplant or grade B eggplant.
That's all from me. Thank you.